reactions of sodium with oxygen. Please take note that sodium reacts with oxygen under two situations. Number one is when oxygen is in excess, and number two is when oxygen is limited. So when oxygen is in excess, keep remembering that chemistry, that the product is sodium peroxide. When oxygen is in excess, the product is sodium peroxide. And sodium peroxide, can you write that one down in your notebook there? We talked about it in senior one, but I'm surprised you keep forgetting. So in excess oxygen, sodium reacts with oxygen to form sodium peroxide, and sodium peroxide is a yellow solid. Then in limited oxygen, the product is sodium oxide. The formula of sodium oxide is still challenging some of you. Sodium has a valence of 1 and oxygen has a valence of 2. So when they exchange valences, you'll have sodium 2 atoms and 1 oxygen atom. So when the question says describe the reaction of sodium with oxygen, the word describe is very broad. It means if there is a diagram, draw it. If there is an equation, write it. Then write a statement. So describe it is like writing an essay explaining what happens. So on that word describe, you should have written all this, because you realize I even gave it 4 marks. So 3 marks are for 2 equations, and the other 1 mark should be for the products. So you say sodium burns with a bright yellow flame. This is always a mark. I told you color of the flame is always a mark. A bright yellow flame forming a yellow solid of sodium peroxide in plenty of air. This plenty of air means in excess air. Yes. So what we need to note is that sodium peroxide is a yellow solid. In limited air, sodium forms a white solid of sodium oxide. So that's what I wanted. That's what I wanted from you. Sodium oxide is a white solid and sodium peroxide is a yellow solid. Please don't ever forget that chemistry. So today, let's use this remaining time to look at the reactions. We are still on, yes, let's look at reaction with chlorine of the alkali metals. And sodium and chlorine, when they are heated together, they form sodium chloride. Now, this equation lacks something. Who can tell us what is missing on this equation? When I look at it, something is not right. Who can tell us what is lacking there? Are you people there on this on the equation? Sodium plus chlorine, we get sodium chloride, but something is missing. Who can identify what is missing for us, what is not right on the equation? Someone just unmute and tell us. Amera?
Yes, teacher.
What's wrong with our equation here?
It's not balanced.
So what should we do?
We put a 2 there, or not 2, I think.
We put a 2 on sodium.
Yes.
No, we should begin by balancing chlorine. And to balance chlorine, you must put a 2 on this compound of sodium chloride behind here, sodium. Then when you put a 2 here, the sodium will become 2. So you also come to the sodium atom here and put a 2 behind it, such that it becomes 2 here and 2 on sodium chloride. And there the equation will be balanced. There the equation will be balanced. The same thing applies here when potassium is heated in chlorine. This equation is not balanced also. We are supposed to put 2. Please ensure that you write these 2 equations in your book such that you correct them when you are writing notes in notes. There is a 2 on sodium here and a 2 on sodium chloride such that the equation balances. Then potassium plus chlorine is also not balanced. There should be a 2 on potassium chloride and a 2 on potassium. Now, reaction with acids. How do those group 1 elements react with acids? So, you know, they are very reactive if you look at the reactivity series. So when they react with acids, remember the knowledge of reactivity series, they will just displace this hydrogen on the acid. They will just displace the hydrogen on the acid. And if sodium reacts with hydrochloric acid, the product will be sodium chloride. Sodium will displace hydrogen and it will form sodium chloride plus hydrogen gas. Then if potassium reacts with sulfuric acid, it will displace this hydrogen and it will form potassium sulfate plus hydrogen gas. So that is it for alkaline metals or group 1 metals. We are now going to alkali earth metals. Now, alkali earth metals, these are elements which are in group 2. So the general name given to elements in group 2, they are alkaline earth metals. Alkaline earth metals. So these are elements in group 2 of the periodic table. Group 2 of the periodic table, it means they have 2 electrons in the outermost shell. 2 electrons on the outermost, in the outermost energy level or shell. If they have 2 electrons in the outermost energy shell, it means to become stable, then they should lose those 2 electrons. So their ions always have 2 positive charges because they lose 2 electrons to become stable. And those 2 electrons are lost by the metal on the left-hand side. So it should be magnesium minus 2 electrons forming magnesium ion. But when the electrons cross equal signs, they become positive 2 electrons. So that's why it is plus here, plus 2 electrons. Now, these elements, they include beryllium, magnesium, and calcium. These are the elements in group 2. And their chemical family is they are called alkaline earth metals. These metals have 2 electrons in the outermost shell, They lose 2 electrons during the reaction to form dipositive ion. Remember di means 2. So when I say dipositive ion, it means to form 2 positive charges. Physical properties, they are harder than group 1 elements. They are good conductors of heat and electricity. They are silvery gray in color. This is their color. However, the shiny surface slowly tarnishes on exposure to air, forming metal oxides. These group 2 elements, they have higher boiling points and higher melting points compared to those of group 1. Okay, this is because they have more electrons in the outermost energy level. So this reason we shall explain it better in senior 5. But for now, in our senior 2, let's know that the group 2 elements have a higher boiling point and higher melting point than group 1s. Let us look at their chemical reactions. Their chemical reactions we begin with reaction with air. How do they react with air? Air, we mean oxygen. And I think you now remember this work that we did in senior 1. How does magnesium react when it is exposed in air? I think you remember that work. Who can tell us how magnesium reacts when it is burnt in oxygen? Someone tell us? Okay, let me remind you to save time. Remember what we said, magnesium, when it is burnt in oxygen, it burns with a bright white flame. It burns with a bright white flame, forming a white solid. The white solid is magnesium oxide. I think I remember very well, we burned magnesium together, either in class or in the lab. So its reaction does not change. Magnesium burns in air, forming a white solid, and the white solid is magnesium oxide. This is the equation. When we ask for the equation, many people forget to balance. There is a 2 on magnesium and 2 on magnesium oxide. Calcium also burns in air with a bright orange flame. I told you, when we ask you to state what is observed when a substance is burnt in air, give the color of the flame and give the color of the solid that is formed at the end. So calcium plus oxygen, it forms calcium oxide. And write this corrected equation also. There should be a 2 on calcium in order to balance it. There should be a 2 on calcium. However, both magnesium and calcium react with nitrogen if oxygen is not in excess supply. Let's take note that magnesium and calcium can also react with nitrogen. They are the only ones actually which react with nitrogen. Calcium and magnesium can also burn in nitrogen. And when calcium burns in nitrogen, it forms calcium nitride. When magnesium burns in oxygen, it forms magnesium nitride. The reason why magnesium burns in nitrogen, it is because when it is burnt, magnesium produces a lot of heat, and a lot of heat will break the bonds between the nitrogen atoms. So magnesium plus nitrogen will form magnesium nitride. Look at that equation. It should be balanced by putting a 3 on magnesium The formula for magnesium nitride, remember, the valence of nitrogen is 3 and the valence of magnesium is 2. Then calcium, the valence of calcium is 2 and the valence of magnesium is also what? Is also 2. So the formula for magnesium, for calcium nitride, we put a 3 on calcium and a 2 on nitrogen. Now there is something very important here. However, when these nitrides are dissolved in water, when these nitrides of magnesium nitride and calcium nitride are dissolved in water, they form hydroxides and ammonia gas. This is the formula for ammonia gas, NH3. NH3, because nitrogen has a valence of 3 and hydrogen has a valence of 1. So when nitrogen combines with hydrogen, the formula is NH3. And ammonia gas is an alkaline gas, so it will be given out in form of bubbles since it is in solution. To balance this equation, remember magnesium atoms are 3, so you put a 3 on magnesium hydroxide, and when we put that 3, the oxygens will become 6. 3 times 2 will become 6, so we put a 6 on water. And when we put 6 on water, remember nitrogens are 2 this side, so we also put a 2 on ammonia. So this part of chemistry is very important. Let us look at reaction with water. How does magnesium react with water? I explained this. Remember when we were looking at the reactivity series and then water and its compounds. We said magnesium does not react with water. So among the group 2 elements, beryllium, magnesium, and calcium, if you follow the reactivity series, calcium is more reactive than magnesium. So beryllium, for it does not react with water under any conditions, whether it is cold water or steam. No, beryllium does not react. But magnesium, I told you, when magnesium reacts with cold water, the reaction is very slow. It can even take 2 weeks. But when you react it with steam, when you react magnesium with steam, it forms, the reaction is rapid and it forms magnesium oxide plus hydrogen. Forms magnesium oxide plus hydrogen. But calcium reacts with cold water. Calcium reacts with cold water, forming calcium hydroxide plus hydrogen. Why? Look at the reactivity series. Calcium is more reactive than what? Magnesium. So in summary, here we are saying group 2 elements, beryllium, magnesium, and calcium. We are saying beryllium does not react with water under any conditions. Magnesium reacts with steam. Steam is water, and I told you water the state should be a gas. Any attempt to put a liquid on the state, you get 0. So the state should be a gas. Magnesium plus water will form magnesium oxide plus hydrogen. Then calcium reacts with water to form calcium hydroxide plus hydrogen. And that is it. We have to stop here for today, but take good note of this. Yes. So that is it for today. I'm going to send you work on Google Classroom, and you should do it in 30 minutes and submit it on Google Classroom. Those who came late, I'm going to send you a recording. Have a good day. God bless you. Bye for now.